Welcome to the anatomy of a great prompt. By the end, you'll learn practical skills to write good prompts and get the most from AI. Let's look at our first key goal. First, you'll master prompt engineering basics by learning to build prompts using four key parts: context, task, constraints, and output formats. This gives you a clear way to write strong, exact instructions for your AI. Next, you'll see common mistakes, learning why many new prompts fail and how to fix them. This helps you troubleshoot well and improve your method. You'll also learn to use existing code files as live examples for Codex. This makes your prompts more dynamic and exact with powerful art references. This method greatly boosts the quality and relevance of the AI's output. Also, you'll make adding negative constraints a regular habit in your prompting. This stops bad outputs and guides the AI better. This habit helps you always get the results you want. Finally, you learn to use challenges to improve Codex's output, pushing it for better, smarter results. By the end, you'll feel sure of your prompt engineering skills. To really master prompts, every good prompt you write for Codex will have the four key parts we just named. Each part helps guide Codex and ensures you get the exact results you need. Let's start with context. Context sets the scene for Codex. It includes all it needs to know about your current situation, like your projects, a file, or current behavior. Giving clear context means giving Codex the full picture to act well. Next, clearly define the task. This is what you want Codex to do, described as a specific outcome, not step-by-step actions. Focus on the results you want, letting Codex find the best way. Then come constraints, the specific rules Codex must follow. These tell it what not to use, touch, or break. By setting clear limits, you guide Codex to make results that fit your project's rules. Finally, specify the output format. This tells Codex how you want the results, like a single function, a full component, an explanation, or just a plan. Defining this ensures Codex presents its solution in the most useful way for you. We've covered the four key parts. Now, let's see why just knowing them isn't enough and how a weak prompt can still fail. Imagine you tell Codex, add a due date to tasks. This sounds clear to you, but it's too vague for Codex. It leaves too much to guess and often gives code that doesn't fit. There's a much better way to reach this goal. Instead of that weak approach, a strong prompt for the same goal gives all needed details. You start with clear context about your app structure. Then define the task as a specific outcome, add important constraints like not installing new libraries, and finally state the exact output format you need. You can see this full approach gives Codex all info to get your desired results precisely, avoiding guesswork. Even with the four key parts, it's easy to make common mistakes that hurt your prompts. Let's look at these pitfalls and how to avoid them. We'll start with the first challenge. Our first pitfall is the context assumption, thinking Codex knows everything about your projects. Even with a good agents.md, Codex needs you to clearly show its surroundings for tasks involving many parts or existing states. To fix this, always ask, what would a new developer need to know to do this right? That's your key context. You'll find that one example often works better than long instructions. We'll make a new task notes component that looks like our task item by linking its files in the prompts. Codex starts by reading the code from the linked files, learning the exact structure and rules of your existing code. Codex is now reading the task item component and its styles. It learns its module pattern and prop-driven shape to use for the new task nodes component. From our task item example, Codex confirms it will use a default export function, the structured props, and a same-named CSS module for task nodes, using the task nodes value. Notice how the new task nodes components files perfectly match task items structure and CSS module patterns. This alignment comes from learning directly from your example. The new components files are ready. Now Codex runs lint to find any style or import issues, making sure our new code is clean. Great, the lint check passed without output, showing our task nodes components fits in without new errors. After lint passes, Codex checks the final diff to show what was added and confirm all is as expected. The final diff shows no output because these are new files. You need to check them manually to confirm all is okay. Codex reviewed the changes, confirming the task nodes components was made in JSX and CSS, matching task items structure. The new task nodes components uses the same default export, property structuring, and CSS module pattern as task item. Class naming matches, and it shows nothing if no node is present. Lint also passed. This process shows how showing, not just telling, lets Codex copy complex patterns exactly and consistently in your project. Okay, with our new task nodes component successfully created, verified, and matching our project structure, we're now ready to save these changes. We'll stage all the newly created and modified files. Then commit them to create a new, clear snapshot in our project's history. We saw how giving Codex live examples shows its exact patterns. Knowing what to do is important, but it's just as key to tell Codex what not to do. This sets clear limits for its actions. Let's look at this important idea now. Positive instructions guide Codex to what you want, but negative constraints are just as vital. These tell Codex what it must not do, setting clear limits to stop bad behavior and keep your project safe. Codex is very powerful, trained on huge amounts of code, and often uses common patterns. Without clear instructions, it might add libraries you don't use or change files you want untouched. Negative constraints are your guardrails. They let you tell Codex to not follow its usual habits to fit your project's needs. To make this clear, here are some examples of negative constraints you can use now. Telling Codex, do not install any external libraries, stops unwanted dependencies. Do not modify app.jsx, ensures it leaves your main app file alone. You can also say, do not change the local storage data structure to keep your app's data safe. Make writing negative constraints a habit, not an afterthought. Before any prompt, pause and ask, what's the most likely way Codex could solve this that I don't want? Then clearly ban that in your prompts. For our to-do app, always ensure do not change the task data structure in local storage. This habit will save you from many bugs and refactoring. The last key strategy for prompts is knowing your interaction with Codex doesn't end after its first output. To get the most, you need to challenge its solutions, pushing for stronger, smarter results. Let's look at 3 strong challenges to improve Codex work, starting with the verification challenge. With the verification challenge, you just ask Codex to prove to me this works by having it show you what happens when a user uses the new feature. You make it trace the logic fully. This is very good at finding flaws early, letting you fix issues before they grow. Once the solution works, you can use the quality challenge by asking, with all you know now, is this the best solution? Codex often admits its first answer was safe or obvious. This makes it offer better, cleaner choices. This gives you good options you may not have thought of, making your code better. Finally, if an initial attempt is truly flawed, use the reset challenge by telling Codex to scrap what you just wrote. This makes it explain its first try's faults before starting fresh with a new approach. While bigger, it's better than trying to fix a bad start. Now you know how to challenge Codex for better results. Let's make sure your first prompts are strong. As you build your prompts, use a simple checklist to cover all key parts. This will help you succeed from the start, and it begins with context. Always start by asking, have I given context? This means giving Codex all it needs to know the current situation, any linked files, and patterns to follow. A well-informed Codex works well. Next, make sure you've clearly defined the task outcome. Describe the result you want. What should be there or work after Codex is done, instead of giving step-by-step instructions. This helps Codex understand what you truly mean. Then consider if you've added constraints. Here, you clearly state what Codex cannot use, which files it must not touch, and any key rules that must stay the same. Remember, negative constraints are as important as positive ones. Finally, always specify the output format. Tell Codex exactly how you want the result, like a plan first, code for certain files, or an explanation before any code. Guiding the format helps you get useful results fast. You've just built a strong base for using Codex, mastering what makes great prompts. Before we dive into advanced features like plan mode, let's quickly review these key ideas and see how far you've come. You now understand what makes a great prompt, starting with its four core parts. Remember, every great prompt has four key parts. By always adding context, a clear task, specific constraints, and the desired output format, you guide Codex to give you exactly what you need. You also learned why many new prompts fail. They lack key info. By finding those gaps and adding context, task, constraints, and output formats, you can now turn unclear requests into exact instructions. We then saw how powerful art references are. They let Codex learn directly from your existing code. This ensures perfect pattern consistency and greatly improves the quality and design of its generated code. You've now added negative constraints to your workflow, making it a habit to tell Codex what not to do. This strong method stops common problems and ensures Codex respects your project's specific limits. Finally, you learn to actively challenge Codex's output, pushing it past its first ideas. By using verification, quality, and reset challenges, you always improve its solutions into truly strong and clean code. Welcome to this lecture on plan mode. We'll explore strategies to enhance your development workflow, enabling you to tackle projects more effectively. Let's begin. First, you'll grasp why a think-first approach, especially with Codex, consistently yields superior results. This foundation will guide more informed decisions from the outset. Next, we'll cover activating plan mode. You must set both the / command and the keyboard shortcut to engage this critical feature. Then discover a powerful feature having Codex interview you. This process uncovers overlooked issues or complex user paths, leading to robust and comprehensive solutions. Finally, you learn an effective method to deconstruct large, complex features into manageable segments. This fosters cleaner, more focused development, allowing Codex to complete tasks incrementally and effectively. Effectively breaking down complex features thrives within a structured workflow. For consistent, superior results on intricate tasks, adopt the research, plan, implement loop. This ensures efficient and precise development. Let's start with research. Research forms your foundation. In this phase, you deeply understand the problem, existing codebase, and user requirements. Thorough research prevents misdirected efforts, saving significant resources. It's about understanding the terrain before building. Next, plan. Here you define precisely what to build and how. This phase allows you to refine critical details and foresee challenges, all before committing to any code. A robust plan streamlines implementation. Finally, implement. With a clear plan established, this phase involves writing code. Your thorough preparation makes this stage highly focused and rapid, ensuring you build exactly what was agreed upon, with confidence and purpose. Plan mode is a Codex feature designed to prevent file modifications. It enables Codex to read, analyze, ask questions, and formulate detailed plans, all without altering your codebase until explicit approval is given. There are two methods to initiate plan mode. The first is the / command. Simply type /plan within an active session, as shown here. The mode indicator will switch to plan, confirming activation. The second method is the Shift+Tab keyboard shortcut. This command cycles through Codex's operational modes, providing a swift way to transition between them. Simply press Shift+Tab until the plan mode indicator appears. While both the / command and Shift+Tab are effective, Shift+Tab offers faster mode switching. Crucially, in plan mode, Codex will not write any files to your codebase, regardless of your prompt. While explicit plan mode activation is effective, you can achieve similar planning without a full mode change for a given task. Clearly state your planning intent within your prompt for more flexibility. Let's see how. Here, you explicitly instruct Codex. Before writing any code, give me a detailed plan for how you would implement this. Do not modify any files until I approve the plan. This clearly, explicitly states the planning constraints, ensuring a plan-first approach. Codex responds by acknowledging the constraint and confirming it will wait for explicit approval before modifying any files, ensuring you retain full control. Before planning a new feature with plan mode, it's best practice to establish a checkpoint. This ensures a clean project state before any modifications or new feature planning. So we'll stage all current changes and commit them with the message pre-plan session checkpoint. First, let's ensure Codex is in plan mode, preventing immediate file changes. Codex is now awaiting instructions. Now I'll describe the desired inline task editing feature, specifically requesting a detailed plan, including edge cases and unknowns, before any code is written. Codex is now processing our request for a comprehensive plan, analyzing all facets of the feature. This may take a moment. Codex provides a detailed response, outlining files to modify, necessary state changes, and critical questions. For instance, it inquires about handling empty text edits, clarifying an ambiguity in the current codebase. As recommended, I'll opt to retain the original task text if an edit is left blank, confirming this crucial behavior. Codex is now incorporating my decision and will continue formulating the detailed implementation plan. Codex has delivered a complete plan for integrating inline editing into app.jsx, tasklist.jsx, and taskitem.jsx, encompassing all necessary code changes, UI interactions, and testing strategies. Upon reviewing the comprehensive plan, Codex requests explicit approval for implementation. This crucial step maintains your full control over all code modifications. With a clear plan, I'm ready to approve. I'll select Yes, implement this plan. Codex is now implementing the inline task editing feature based on the approved plan. This phase translates our detailed strategy into functional code. Codex confirms the commencement of building, verifying the projects for uncommitted files, and reviewing components to ensure a clean state. Codex proceeds with implementation, meticulously applying changes to project files as outlined in our plan. Codex shows the changes, incorporating edit state into app.jsx, prop drilling through task lists, rendering editable inputs within task item, and introducing task-config.js. The detailed diff comprehensively displays modifications across multiple files. Codex confirms the primary edit flow is established and is now adding focus tests for diverse editing behaviors, including double-click, save, cancel, and managing blank saves. Here, observe the detailed diff for the newly added tests, illustrating how Codex ensures robust coverage for all inline editing features and edge cases. Codex reports on test coverage, initiating linting and test runs for the new features. It confirms a clean lint, passing editing tests, and our known unrelated starter test failure. During test execution, Codex continuously monitors, ensuring all checks pass before proceeding. Codex confirms a clean lint and all new editing tests pass. It then performs a production build as a final verification, completing in under a second. The production build is executing, verifying all changes are production ready. The production build passes. We'll now review the final diff and stages. Codex summarizes all modifications. All verifications pass with only one known and related starter test remaining. Having seen Codex swiftly build a feature from a clear plan, let's explore a more robust approach for larger, complex editions. This involves leveraging Codex to define requirements before planning commences. Let's examine the initial interaction. Here, you initiate a dialogue with Codex rather than just assigning a task. You explicitly instruct it to interview you, intuitively posing critical questions to correctly architect a tagging system. This powerfully guides the development process. Codex immediately recognizes the value of this needs clarification. Its initial question addresses a core design choice. Should tags be freeform or selected from a predefined list? This fundamentally impacts the data model and UI. You provide a clear answer, opting for freeform tags to maximize user flexibility. This informs Codex in devising the optimal implementation. Building on your previous response, Codex poses its second question, clarifying tag cardinality. It asks if a single task can accommodate multiple tags, a critical data structure detail, a single string, or an array. You promptly confirm that tasks should support multiple tags, reinforcing the data model requirements for the tagging system. Codex then inquires about data persistence, specifically how to store the list of tags. This highlights a trade-off between immediate simplicity and future flexibility, such as dedicated tag management interface. You opt for simplicity initially, stating the full tag list can be derived from existing tasks as required. This maintains a focused initial scope. For its final question, Codex shifts to UI and user experience, asking if tags require unique persistence colors. This demonstrates its ability to uncover unarticulated visual or interactive requirements. By indicating that colors can be omitted for the initial version, you actively define and manage the project scope, prioritizing essential features for the MVP. This strategically mitigates early complexity. With your comprehensive answers, Codex now possesses a precise understanding of your requirements. It summarizes the plan, ensuring every detail aligns with your choices, and is prepared to formulate a tailored implementation plan. With a clear plan and needs defined via interview, the next critical step for clean development is mastering scoping to win. This involves decomposing complex features into small, testable segments, enabling Codex to address one concern at a time. Let's examine the first slice for our tagging system. For slice 1, data structure. You'll primarily enhance your data model. This entails incorporating tag data into the task objects within local storage, establishing a robust foundation before UI modifications. Next, for slice 2, input and creation. You'll integrate the ability to assign tags directly within your task input component. This addresses the initial creation workflow, allowing new tasks to receive tags upon generation. Then slice 3, display tags, focuses on presentation. You'll render these tags on the task item component, making them visible as a simple display once data integration is complete. Finally, slice 4, the filter bar, completes the core feature by enabling users to filter tasks by tag. This will be achieved by either extending your existing filter bar or introducing a new component to manage this interaction. With our inline task editing feature built and verified, let's commit these changes. First, it's prudent to review modifications, run git diff to inspect what will be committed and identify any new Antrax files. Then stage your changes and commit them with a concise message, maintaining a clean project history. Beyond its precision, plan mode also inherently protects your context window, a significant efficiency benefit. When Codex proceeds directly to implementation, context is rapidly consumed. Planning, however, operates differently. Let's delve into why. Direct implementation causes rapid context consumption through reading, writing, and executing code. Planning, however, is predominantly a text-based conversation. This allows you to leverage Codex's analytical capabilities without the significant context overhead of code modification. By front-loading critical thinking into the planning phase, you incur only a fraction of the context cost compared to immediate coding. Consequently, the actual implementation phase becomes highly focused, remarkably swift, and far more efficient. You'll build precisely what's required with minimal friction. You've now grasped the core concepts of plan mode, a vital skill for effective Codex utilization. We've observed how a think-first approach transforms your development process, yielding stronger, faster solutions. Let's quickly review the key takeaways, beginning with planning's fundamental benefits. First, you comprehend why pre-coding planning consistently delivers superior, faster results. This deliberate approach mitigates common issues and significantly reduces defects. Next, you learn plan mode activation. You can swiftly engage it using either the straightforward / command or the quick shift tab shortcut, placing Codex into planning mode. You also acquired a powerful technique, having Codex interview you. This skill uncovers latent requirements and critical design considerations early, saving substantial effort downstream. Crucially, you discovered an effective method for decomposing complex features into discrete, manageable parts. This approach streamlines development, simplifies reviews, and enhances step-by-step success. Finally, you grasp the significant benefits of planning, preserving your context window. By front-loading the thinking, you render subsequent building phases more focused, rapid, and highly efficient.
Thanks for watching. If you like this, you'll love Zenva Academy. 300 courses where you learn AI by building real apps. Links in the description.